Okay, so I guess we can start now. So, today I'll just be going over factorials and divisibility, and we'll go over like factorials for the beginning of class, but we might spend a little more time on it, so the rest of the divisibility questions will just be for homework. Okay, so let's get started. So, assuming you guys all know what a factorial is, we kind of did a question with factorials last week, but just like if you guys don't know what a factorial is, we have that n factorial equals n times n minus 1 times n minus 2 all the way to 1, right? So it's just like the product of all of these numbers. So then we'll just like I'll just let you guys read this problem for a couple seconds and then we can go over it. Okay, so we can start now. Okay, why is the factorial after the parentheses? It's, oh, okay, are you talking about number 2? Well, we can just ignore that for now, and let's just like, focus on number 1. This class is Math Contest 1, and we'll just like be going over, late AMC 8 to like early AMC 10 problems. Okay, so let's just start by like, do you guys know what the symbol means? Well, the symbol just means like the sum of. So the sum of, this just means the sum of 1 factorial squared plus 2 factorial squared all the way to 100 factorial. Oh, sorry. 100 factorial squared, right? So that's just what this fancy symbol means. Right, it's sigma. Okay, so we can start by saying we can start by looking at each terms individually, right? So then 1 factorial is 1, so 1 squared plus 2 factorial is 2 squared, 3 factorial is 6 squared, 24 factorial is 24. I mean, 4 factorial is 24, so 24 squared, and then 5 factorial is 120, right? And then from here, we realize that 6 factorial equals 6 times 5 factorial, right? And we know that 5 factorial ends with a 0. And then if you multiply a multiple of 10 with an integer, then we just get another multiple of 10. So 6 factorial also ends with a 0, right? So we can just discard everything from 5 factorial onwards. So like none of this matters. So now we look at this part. So we know that 1 factorial ends in 1 because it's just 1. 2 squared ends in 4, 6 squared ends in 6, and 24 squared ends in 6. So if we add this up, we get it's 17, and the units digit is 7. So the final units digit is 7. So do you guys have any questions? If you guys have any questions, you can put it in the Q&A. Okay, so do you guys want me to like turn off the chat, or is this like because it's distracting, or do you want me to just leave it on? Okay, so you guys, I mean, I think you guys want to, okay, I'll just turn it off because this is like kind of distracting. Give me a minute. Okay, I think that's good. Okay, so now if you have any questions, you can just put it in the Q&A section. Oh, okay. So if we don't have any questions with this problem, we can move on to the next problem. Okay. So you guys can read the problem, and then I'll let you guys, and then I'll go over it in a couple minutes. Okay, so let's start. So then let's look at this. So what does n plus 1 factorial mean? So n plus 1 factorial equals 1 times 2 times 3 times all the way to n times n plus 1, right? And then we can rewrite this as, because we know the first part is n factorial, so we can rewrite this as n factorial times n plus 1. Okay, right? So then rewriting this equation, we can have n plus 1 times n factorial plus n plus 2 times n plus 1 times n factorial equals n factorial times 440, right? So if you guys are wondering where I got this from, you can see that n plus 2 factorial, if we write it all out, it's just 1 times 2 times 3 times all the way to n plus 1 times n plus 2. And then rewriting this, we can see that this is just n factorial, and then this is n plus 1 times n plus 2. And then factoring out the n factorial from both sides, we get that n plus 1 plus n plus 1 times n plus 2 equals 440. And then we can factor out the n plus 1 to get n plus 1 times 1 plus n plus 2 equals 440. And this is just the same as n plus 1 times n plus 3 equals 440. And then if we just like look closely at this number, this is like almost 21 squared, right? 21 squared equals 441. And this is like almost 21 squared, so we can just have this as like, we can see that this is 20 times 22. And then since n plus 1 equals 20, n equals 19, and then the sum of the digits is 10. So any questions? Okay, I think all of the questions have been answered, so I'll just like, if there's no more problems, we can just move on to the next question. Number 3. The base 10 representations for 19 factorial is this big number, and then where T, M, and H denote digits that are not given. What is T plus M plus H? And then I'll give you guys a couple minutes to think about this, and then we can start solving it. All right, let's get started. So we have 19 factorial equals 1 times 2 times 3 all the way to 18 times 19, right? And then look here, we have 2 zeros already. So we know that we have, we need to look at the number of multiples of 5 we have in here. So there's 5, okay, so there's 5, 10, and 15, right? So then there's a 10 here, and we can just like cancel this part out. And then we see there's a 2 and a 5, so we can cancel this part out, right? But we are left with a 15, and then we have like 18 or whatever, or like another multiple of 2, and we see that there has to be another 0. Like if this is 14, then it's 60. So there's another multiple of 0, so H equals 0. Are you guys all good with that? All right. So then, okay, so then let's look at this thing. We know that this whole thing is divisible by 9, right? Because there's like a 9 in this, like 18 equals 2 times 9, right? So this whole thing is divisible by 9. And then we know that if a number is divisible by 9, then the sum of its digits are divisible by 9, right? Do you guys know that? Okay, so with the divisibility rules, we have that if a number like x is divisible by 9, then all of the digits of x, all the digits summed of x are like divisible by 9. So let's say that we have 81, right? We know that this is divisible by 9, right? And 8 plus 1 is also divisible by 9. We can go into the proof later, but it's not really necessary. We can just use it to solve the problem, unless like you guys want to. Okay, so let's say that we have ABC, a number ABC is divisible by 9, right? Then we also have that A plus B plus C is also divisible by 9. Oh, not equals 9. Is divisible by 9. Like 9 divides ABC, so 9 divides A plus B plus C. Are you guys good with that? Okay, this is just a divisibility rule that we know. We don't have to go into the proof right now, unless you guys like really want to. So let's add up all the digits, right? So we have 1 plus 2 plus 1 plus 6 plus t plus 5 plus 1 plus 4 plus m plus 8 plus 3 plus 2. I just ignored all the zeros because they're like irrelevant to the sum. And then we know that 6 plus 1 plus 2 is divisible by 9. We know that 5 plus 4 is divisible by 9. 8 plus 1 is divisible by 9. So we're left with 6 plus t plus m is divisible by 9. So this could either be 9 or it could be 18 or 27 or something. So then if it was 9, then t plus m equals 3. And then if it was 18, then t plus m equals 12. And if it was like 27, then t plus m equals 21. However, this is not possible because the greatest t and m can be is 9, so 9 plus 9 is 18, so this one is not possible. Now the second divisibility rule that we're looking at is divisibility by 11. So the divisibility rule for 11 is if we have like A, B, C, D, E is divisible by 11, then we know that like A plus C plus E equals b plus d plus 11x for some x, like if x was 0 or 1 or something. So are you guys all good with this? Okay, so that's the divisibility rule for 11. So applying that to this number, we see that since there's 11 in our factorial is divisible by 11, then we can just then we can look at these numbers. So we have 1 plus 1 plus t plus 1 plus 0 plus 0 plus 8 plus 2 is okay, so what is this added up? This is 2 plus t plus 3 plus t 13 plus t. 13 plus t equals 2 plus 6 plus 5 plus 0 plus 4 plus m plus 3. Can somebody add this up for me? Let me see. Okay, I think this is 20 plus m. Like, you guys can correct me if there's a mistake. Thus, we have that t equals 7 plus m, or plus 11x. Plus 11x, right? Now, we can either have that, if t plus m equals 3, then we have that, okay, then if t plus m equals 3, right, then t is less than 7, so we could have t equals 7 plus m minus 11, like we can have this, right, because it can't be plus 11. So then we have t equals m minus 4, and then we know that m is less than 3, so m is less than 4, so this would be a negative, so this doesn't work. So then if t plus m equals 12, then we have that t equals 7 plus m plus 11x. Let's say that x equals 0, so we can just like ignore this part. Then we have that t equals 12 minus m. 12 minus m equals 7 plus m. So 5 equals 2m. So this also doesn't work. So then we can have that x equals 1, so plus 11. Sorry. Oh, can I say what again? Oh wait, sorry, I was looking at the wrong question. Anyways, yeah, we'll keep on going. So now we have that 11. So x cannot equal 0 and it cannot equal 1, right? When t plus m equals 12. So then we can do a negative one. So we can have t equals 7 plus m minus 11. So t equals m minus 4. And then if we have t plus m equals 12, then t equals 12 minus m. So 12 minus m equals m minus 4. So 2m equals 16, so m equals 8 and t equals 4. So then t plus m plus 8 would equal 4. 8 plus 4 plus 0, so that's 12. So we just have to try the cases over here and see that x has to be -1 and t plus m has to equal 12. Very good. So if you guys have any questions, you can put it in the Q&A section, and then I can help you guys answer your questions. Alright, so since there's no questions, we can go on to the next problem. What is the hundredths digit of 20 factorial minus 15 factorial? And I'll just give you guys a couple seconds to think about it. Oh, okay, so I can see that some of you guys have already gotten the answer, so I think we can just go over it right now. Now let's look at how many zeros 20 factorial has, or how many zeros 20 factorial ends in, right? We can look at the multiples of 5 in 20. We have that there's 5, 10, 15, 20, right? So we know that there are more multiples of 5 than multiples of 2, so then each of these would end in a 0, so there would be 4 zeros, right? Because we can pair this up with 2, and we can pair this up with like 12 or another multiple of 2, and then it gives us 4 zeros. And then 15 factorial has 5, 10, and 15, and that's 3 multiples of 5, so there's 3 zeros. And then, so if it's a number that ends in 4 zeros minus a number ending in 3 zeros, we would always have 3 zeros left, right? So then the hundredths digit, this is the ones digit, tens digit, hundredths digit. The hundredths digit always has to be 0. So that's our answer, because there are 3, these all end in more than 3 or more zeros. Okay, so do you guys have any questions about that? Okay, so if there's no questions, we can be moving on to the next problem. Okay. What is the least positive integer n such that 1560 divides n factorial? And I'll just give you guys a couple seconds to think about this. Oh, I have a question about the previous problem, so let's go back to the previous problem. Okay, why doesn't 20 times 19 times 18 times 17 times 16 minus 1 work? So you're telling us to factor out the 15 factorial, right? So if we factor out the 15, oh, let's see. Let's factor out the 15 factorial here, right? So you can factor out, okay, so we know that 20 factorial, okay, let me write this. Okay, so 20 factorial equals 20 times 19 times 18 times 17 times 16 times 15 factorial, right? So factoring out the 15 factorial, we get 15 factorial times 20 times 19 times 18 times 17 times 16 minus 1, right? So why doesn't this work? Oh, fact. Okay, so wait, let's see. So then we know that 15 factorial ends in 3 zeros. So it's like somewhere in the it's like 1,000 times something. So if it's, since it ends in 3 zeros, we can write it as 1,000x times 20 times 19 times 18 times 17 times 16 minus 1. And then this already ends in 3 zeros, so we know that the hundredths digit is 0. Okay, I hope that answers your question. Does that answer your question? I'm not sure what you mean by factor out the 20 factorial, because the 15 factorial is not a multiple of 20 factorial. Okay, let's go to the next problem. 5. So for problem 5, does it mean greatest? Because least is just 1 factorial. So we want 1560 to divide n factorial, like not n factorial divides 1560. Does that make sense? Like we want 1560, like n factorial over 1560 is an integer. So I hope that answers your question. Oh yes, we can start on this problem. I think you guys had enough time to think about it. Okay, so starting off, we should prime factorize 1560 because we want it to divide n factorial. So 1560 is, can somebody prime factorize this for me, or should we do it all together? Okay, so I can just prime factorize this for you. So we know that this is 2 squared, right? And then dividing this by 4, we get that it's 390. Wait, actually, give me a minute. Okay, so this is 2 cubed, I think. Times 5 times times 3 times 13. I'm pretty sure this is a prime factorization, but if I did something wrong, you guys can tell me. Yes, so I'm correct. And then now we want n factorial to divide this number, right? And then what we're really focusing on right now is this 13, because it's a prime number, and we know that 12, it's not in 12 factorial or 11 factorial or any of those numbers, and it's in 13 factorial and onwards, right? So we want to see if 13 factorial contains 2 cubed, 5, and 3. But then we know that 2 cubed equals 8, 5 equals 5, and 3 equals 3, and we know that 13 equals 13 times 12 times 11 times not 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we can see that the 8 is found in here, the 5 is found in here, and the 3 is found in here. So the least positive integer n such that 1560 divides n factorial is 13, because 1560 divides 13 factorial. So if there's any questions, just put it in the Q&A. Oh, okay. So if there's no questions about this problem, we can move on to the next problem. Or do you guys just want to break for 2 minutes right now? Okay, so we can break right now, and then we'll come back at, how long do you guys? Okay, since this is the last day, I'll give you guys a longer break, and we can come back at 3:33. Is that good for y'all? Okay, and yes, so somebody said that you can see the answer on number 6, and I guess it's just because I forgot to take it off while I was making the problem set. So it's fine. We can just go over the solution. It's not really finding the answer. It's like looking for the solution. Okay, so we'll meet back at 3:33. Okay, so somebody asked what question we're gonna do. The next question we're doing is number 6, and then we'll just go from 6 onwards. Oh, okay. I think we can start. We can start now. Okay, so let's look at number 6. The digits of a 4-digit positive integer add up to 14. The sum of the two middle digits is 9, and the thousandths digit minus the units digit is 1. If the integer is divisible by 11, what is the integer? I know that the answer to this one is written on the board, but we can just like ignore it for right now, and then we can find the answer by ourselves, right? Okay, so let's start. So we know that, let's say that this 4-digit number is A, B, C, D, right? So we have that A plus B plus C plus D equals 14. And we know that B plus C equals 9 and that A minus D equals 1. So this is a lot that we are working with, right? So then, if you guys remember, actually we can just start with this. We have that, since A plus B plus C plus D equals 14 and B plus C equals 9, then we have that A plus D equals 5, right? And then since we know that A minus D equals 1, we can get that 2A equals 6, A equals 3, and D equals 2. Okay, and now using the divisibility rule of 11, we know that this equals this. So we know that A plus C equals B plus D plus 11x, right? So we know that 5 equals B plus D plus 11x. But we know that, not 5. We know that A minus D equals B minus C plus 11x. So we know that 1 equals B minus C plus 11x. So let's say that if x was 1, then we got that 1 equals B minus C plus 11. So we get that C equals B plus 10. And this is impossible because the digits range from 1 to 9. So x cannot equal 1. If x was negative 1, we would get 1 equals B minus C minus 11. And then doing this, we would get that B equals 10 plus c, which again doesn't work because the digits range from 1 to 9. So then we know that x will have to equal 0. So if x equals 0, we get that 1 equals b minus c. So b equals c plus 1. And then if b equals c plus 1, we can plug this back into our equation here to get that 2c plus 1 equals 9. So c equals 4 and b equals 5. So then our number would be 3, 5, 4, 2. This is our answer. Do you guys have any questions? Alright, so it doesn't look like you guys have any questions, so we can go on to the next problem. Okay, so looking at this problem, I'll give you guys like a minute to look at it, and then we can go over it after the minute is over. Okay, let's start with this problem. I saw that some of you guys have already gotten the correct answer, so that's good. Alright, so let's start. We can start by looking at the amount of 2's that are in our product. So if p lands on 1, okay, let's see. So there's 1, 2, 3, 4, 5, and 6, right? And we want the product of 5 of them. So then for the 2, the amount of 2's in here right now is 1, 2, 3, 4. So 4, right? There's 2 to the 4 in this right now. And we want the least possible numbers of 2. So if we don't include 4, then we only have 2, 2, so it's only 2 squared, right? So then we have to use 2 squared. Oh, so many questions. Okay, and then now we can look at the 3. So in our number initially, we have 3 squared, right? But then if we land on, let's say, 6, then we can't have 6, so there's only 1 3, so it's just 3 to the 1. And then let's say for 5, there's 5 to the 1 here, right? But if we land on 5, then we'll have 5 to the 0. So multiplying this together, we have 2 squared times 3 to the 1 times 5 to the 0, and this is just 12. So do you guys have any questions on this, or is this good? Okay, so I think you guys are good with this problem, and then we can just move on to the next problem. So, one morning, each member of Angela's family drank an 8-ounce mixture of coffee with milk. The amounts of coffee and milk varied from cup to cup, but were never 0. Angela drank a quarter of the total amount of milk and a sixth of the total amount of coffee. How many people are in the family? Okay, so this one is maybe I'll give you guys a little more time to think about this one because this one's a little hard. So I'll give you guys until like 3:43. That's good. Okay, so somebody asked me if we can go over number 7, so I guess we can just go over number 7 again. Here. So, let's say that you have a dice like this, right? And then let's say that the bottom number is 6, right? If the bottom number is 6, then P equals 1 times 2 times 3 times 4 times 5. And then if the bottom number was like something like 5, it would just be 1 times 3 times 4 times 6. So it's all the numbers except for the bottom number multiplied, right? So then if we include the bottom number, we have that 6 factorial equals 720. And then this has 2 to the 4th times 3 to the 1 times 5. I mean 3 squared times 5, right? Okay, so however we know that this has to land on one of the numbers. So if it landed on 5, then it would just be 2 to the 4 times 3 squared times 1, right? Because there would be no multiple of 5. So we can't include the 5 as certain to divide P. So then let's say that we landed on 4, right? If we landed on 4, then we would only have 2 squared, not 2 to the 4th. So we don't know that 2 to the 4th is certain to divide P. And then lastly, let's say that you landed on 3. If you landed on 3, then you only have 3, there's only 1 3 and not 3 squared. So only 1 3 is certain to divide P. Alright, so multiplying this together, we get 12. Do you guys have any other questions on this problem? Okay, so if there's no more questions, we'll go to number 8, and then with number 8 we can I'll just give you guys until 3:45, and then we can solve it at 3:45. Okay, I think it's time to start solving this problem. Okay, so if you want to see, like, if we want me to reply to your answer, you should just put it in the question and answer section. Okay, so let's start with this problem. One morning, each member of oh, okay, I already wrote this. So let's say that Angela drank X ounces of water, X ounces of milk and Y ounces of coffee. And you know that this is an 8-ounce mixture, right? And then that means that the total family is 4x plus 6y equals a variable 8a, right? Let's say that a is the amount of people in the family. So then multiplying by 4, we get that 4x plus 4y equals 32. And then subtracting this, we get that 2y equals 8 times a minus 4, right? So we know that y equals 4 times a minus 4. So y is a multiple of 4. That means that y equals 0, 4, or 8. Okay, so if y was equal to 0, then x equals 8, and that means that 4x plus 6y equals 32, right? So she drank 8, oh, actually, sorry. If y was equal to 0, then x equals 8, right? However, we have to keep in mind that the amounts of coffee and milk vary from cup to cup, but we're never 0 here. We're never 0, right? So then we cannot have y equal to 0 here. And then if y was equal to 8, then we have that x equals 0. And then that's again not possible because it was never 0. So we know that y equals 4, and this means that x equals 4. So Angela drank 4, right? 4 ounces of coffee and 4 ounces of milk. And then let's say that another member in the family drank 5, 3, and then 6, 2. Right, drank a quarter of the total amount of milk. So the amount of milk that exists is 16, and then the amount of coffee, was 24. Okay, so then adding this up, we get that this equals 40, right? And then if this equals 40, we can divide it by 8 to get that, there are exactly 5 people in the family. Okay. Oh, whoops. So my pen is like not working, which like happens every class for some reason. I don't know why this is not working. Okay, anyways, so we just get that 16 plus 24 equals 40, and then 40 divided by 8 equals 5, so there's 5 members of the family. If you guys have any questions, you can put it in the Q&A section. Okay, so it doesn't look like you guys have any questions, so we can go on to the next problem once I get my pen to start working again. Alright, let's go on to number 9. You know what? Number 9 is like a really simple question, so I guess we can just skip it and come back to it later if we have time. Well, actually, you know what? Let's just focus on number 11 right now. Actually, you know what? You guys can pick a number because I don't. Let's see. What is the most fun problem on here? Okay, you know what? We'll just do number 10. So then I'll just give you guys until 3:52 to read number 10, and then we can go over it. Oh, sorry. Okay, is this better for you guys to see the problem? Number 10. Okay, I guess since you guys didn't see it, I'll just give you guys until like a couple seconds to like look over it. Okay, let's start. Alright, so let's see. Find a positive integer that is divisible by 14 and has a square root between 25 and 25.3. So we know that the square of 25 is 625, and then we know that the square of 25.3, right, we can just like say that it's let's say that it's oh, you know what, let's just like ignore that for now because it's like a not nice number to work with. So then let's find a positive integer that is divisible by 14, right? And we know that 700 is divisible by 14. And then we know that 98 is also divisible by 14, so we know that 602 is divisible by 14. Adding 14 to this, we get that it's 616, which is still less than 625, so we add another 14 to get that it's 630. So let's find that 630. And then we want 630 to be less than 25.3 squared, right? And then if we square 25.3, I think this squared equals like 640 point something, or yeah, I'm pretty sure this is 640 point something. And then we see that 630 is between these two numbers, so we know that this is the positive integer that is between these two. You guys have any questions? Okay, so if you guys don't have any more questions, we can do one last problem. Right, let's see, what problem do we want to do? I guess we can just go on to number, do you guys want to, okay, we can just go on to number 11. I'll give you a couple minutes to read this problem and then we'll solve it. Oh, how did I estimate 640? I didn't estimate 640, I just multiplied 225.3 out. We can just multiply it out, like, and then if we multiply it out, we get like 640 something. Okay, so let's just do number 11 starting right now. So what is the largest n such that a equals 2 to the 306 times 3 to the 340 is a perfect nth power. So then we want it to be in the factorial of 2 times 3 to the n, and this is 2 to the n times 3 to the n, right? So we want n to divide 306, and we want n to divide 340. And you know that 340, we can see that 340 equals 34 times 10, right? And then we know that 306 equals 340 minus 34. So we can write this as 34 times 10 minus 1 equals 34 times 9. So then the greatest common divisor of 340 and 306 equals 34. So we get that the largest n such that a is a perfect nth power is 34. So if you guys have any questions, you can put it in the Q&A section. Okay, so I don't think it doesn't look like there are any problems, so I think we can finish with this for the day, and then the rest of the problems will be homework for you guys. Andy, do you know which one you want to be made host?
Yeah, could you make the other one host?
The one without the video?